Let's try to understand GPCR signaling in the artery system, how this is working in the arteries. First, we need to know few concepts like blood vessels are made up of three layers. One is tunica externa, tunica media, and tunica intima. There are three layers are forming in the blood vessel. Okay, and also we need to know the contraction and dilation process. The contraction is nothing but narrow region of the blood region is known as contraction, and the wider one is known as vasodilation process. In this process for the GPCR, there are NO gases present known as nitric oxide, which is hydrophobic in the condition. And what we are doing in this all process, we are doing the vasocontraction to the vasodilation. So the contracted vessels are getting converted into the dilated, means they will be wider in the space, larger. Okay. So what really happening here, you can see this is a tunica intima layer and this is tunica media layer. In this tunica intima layer, what really happened, acetylcholine will come and bind on the GPCR, as we know very well about the GPCR receptor. After it will get bind, it will add or activate the GEF activity. So the GEF will attach GTP on the alpha subunit. So GTP will move from here to this. So beta and gamma will remain on the near to the GPCR receptor. But alpha will move towards the PLC, means phosphorylation. This PLC will break PIP2 molecule into the DAG and IP3. So this IP3 will go towards the ER and attach on the plasma membrane and make a channel. Because of the making channel, it will release some calcium. This calcium will attach with the calmodulin and CAM kinase. So they are forming CCC complex, because here C, this C and these three C's are more making the 3-cis complex. After formation of the complexes, what it will do, it will activate the NO synthase by adding phosphate on it. So after activation of the NO synthase, it will go towards the arginyl amino acid and convert this arginyl into citrulline and NO gas. This NO gas can able to move from the one cell to another cell like tunica media. So it is moving towards tunica media from the tunica intima. So it will travel through here and it will attach on the guanyl cyclase and use GTP and make CGMP. As we know very well, CGMP is nothing but secondary messenger. So what it will do, it will activate protein kinase G. This is in inactive condition, then PKG will get active. So it will active some another proteins also. So the vasodilation gonna happen. So the contraction vessel gonna be converted into the dilation process. This is what really working for the GPCR. This is acetylcholine, which is working as a ligand. The acetylcholine are responsible for the secretion of the saliva as well as for the muscle contraction, and also it is responsible for the dilation process in the blood vessels.